So here we've got a problem where we're going to find the area bounded by the given curves. Y equals x minus 2. And then something a little weird, it's x equals y squared. Okay? So maybe you have seen something like that before, but maybe you haven't. Now, when we go to graph this, oh, not that. Let's do this. Okay. So I'm going to count by 2 blocks to be 1. Like that. Okay. And so this is my y-axis, and I've got my x-axis here. Okay. And here's what we're going to do. First, we're going to graph the line y equal x minus 2. So this is mx plus b form. So I start at my b at the negative 2. And then I see that I've got a slope . So I see that I have a slope of 1 positive. So up 1 over 1, up 1 over 1, up 1 over 1, all the way through here. Okay. I'm sorry, there's something. What am I doing wrong here? Yeah, all right, I'm good. Okay, so now comes the part that may be a little bit more challenging for us. Okay, so this part is how do we graph x equal y squared? You've got 2 options. One, you rewrite this as a function of x by solving for y. So what do I mean by that? So I have x equals y squared. Well, how do I get y by itself? I square root both sides. So I have y equals plus or minus the square root of x. So that means y equals square root of x, or y equals negative square root x. Okay? So how does a square root x function look? Well, it starts at 0, and at square root of 1 is 1, square root of 2 is 1.4 something, square root of 3 is 1.7 something, square root of 4 is 2, and then it just keeps going kind of like that, right? Now, the negative branch, okay, because there's another branch, is going down the opposite way here. Is the y value, instead of being positive, is negative. Oops, sorry. Let me redo these dots. Kind of like that right there. So the region bounded is this region right here. We want to find the area of that enclosed bounded region. So you could, technically you could, if you wanted to, you could do this dx, but is it dx easy? So the top is always the top, but what happens here, the bottom is a line on this portion right here. But as we move over to here, now the bottom becomes the negative square root x curve. And the top is the positive square root x curve. Okay? So if you were going to set up this integral in this way, you'd have to break it up into two integrals. Right? And I don't want you to solve this, I just want to show you what you would have to do. You'd integrate from, looks like 0 to 1 of the top minus the bottom, right? The top minus the bottom, which the top minus the bottom would be square root x minus negative square root x. The bottom is the negative square root x. There's the top right there. And then dx. And then plus the integral from 1 to 4 of the top, which is square root of x, minus the bottom, which is that line, x minus 2 dx. And you could get the area, this green area here, by doing that like that. But in this video, I want to show you how to do this problem where it's y easy. So this is not a good problem to do x easy on. This is a good problem to do y easy on. So that's what we're going to do here in this video. I'm going to show you how to solve this problem, okay, where you're using y easy. Now I solved for y here so that I could graph it easier. The other way to treat it, when you see something like x equals y squared, the way I like to do it in my head is I think, okay, my brain works normally with y equal x squared. Well, I know that y equal x squared is a parabola centered at the origin, right? But what is the difference here? I'm literally swapping my x with my y. So you see how the parabola for y equal x squared hugs the y-axis. Well, all that I'm doing is I'm taking that and I'm swapping my x with my y value. So instead of hugging the y-axis, now I'm going to hug the x-axis. So I take my parabola and I just turn it. I just turn it, and I like to call this the tilt yo head method. Okay, this is the tilt yo head method. All right, so you just tilt your head to the right, and that's what that graph will look like. And so there you see that it looks just like that. So I've literally I've swapped out the x with the y. Okay, so that's kind of how I think about it. All right, and so that helps me. And if all else fails, you can always just plug in values and plot points. Okay, so enough of that. Let us now find the area dy easy. So what does that look like? So I'm going to draw my dy. Okay, is the line always the right side? Yes. Is the left side always the parabola? Yes. So it is dy easy. Okay, so dy, so that's y easy. And if we think about the y easy formula, the area is equal to what? Integral from what? Bottom to top. Okay, so the bottom to top. Remember, the bottom is a y equal, a horizontal, right? What y value do we start at? To the top, where do we stop? What y value do we stop at, right? So we're summing up all the rectangles from y equal -1 all the way up to y equal to 2. So we're summing up. We're doing an integral. We're summing from bottom to top, -1 all the way up to 2. And then what is it? It's from right to left, right minus left, dy, right? So it's the far right side minus the left side. Okay, so for this particular problem, what do we have going on? So that's the tilt your head method. Let's try this again. Okay. And so this is going to equal, starting from -1 up to 2, we sum from -1 all the rectangles between -1 and 2. That's the elongated S is your sum. Okay. And then right minus left. So the right side is the line here. The line is the equation x minus 2. Okay. X minus 2. And then minus the left side is this over here. Now the left side is this equation x equals y squared. And then what am I integrating with respect to? Y. Okay, now you might be at this point thinking, Mr. Clark, you done messed up. And I did this mess up on purpose because I want to show you why this is wrong and why you should look and think, what did I do here? I'm integrating with respect to y, but I've got an x in there. So how do I fix that? Because I need it to be in terms, remember, these are functions. This is a f of y and this is a g of y, right? I want it to be in terms of y, not x. So how do I fix that? Well, if I have y equals x minus 2, that's a function of x, not a function of y. So I need to solve for x. I need x equals something. Okay? X needs to equal something. So how do I solve for x for this problem? I'm going to add 2 to both sides. And so x is equal to y plus 2. So this gets replaced. Instead of x minus 2, it's y plus 2. Okay? Y plus 2 goes in here. So got to be careful there. All right? If I'm integrating with respect to y, everything in here needs to be in terms of y. Okay? So it's y easy. So you write it in terms of y. So right there, you had it already set up, x equals y squared. But this one was y equals x minus 2. So to make it x, I add 2 to both sides. And now I have x equals y plus 2. So I have x equals something, x equals something. Those are my somethings that go inside here and here. Okay? Right minus left. So whenever I integrate this, what do I get? I get, well, -1 to 2, negative y squared plus y plus 2 dy. That's negative y cubed over 3 plus y squared over 2 plus 2y, evaluated from -1 to 2. Oh my goodness, I'd rather hit my finger with a hammer or something, right? This is ridiculous. Okay, so plug in 2 cubed over 3 plus 2 squared over 2 plus 2 times 2. Yuck. All right, and then minus negative 1 cubed over 3 plus -1 squared over 2 plus 2 times -1. Goodness gracious. All right, so that's -8 over 3 plus 2 plus 4 minus, and then minus, that's plus 1 over 3 plus 1/2, and then minus 2. If I mess up my arithmetic, don't judge. All right? Minus 8 over 3 plus 6 minus 1/3 minus 1/2 plus 2. So 6 is 8. Negative, that's -9 over 3, which is -3. So minus 3 and then minus 1/2. So 5 minus 1/2. So that's 10 over 2 minus, so that's 9 over 2. Holy smokes. Is that right? Take a 3. Yeah, okay. I think that's correct. Okay? So So 9 over 2 sounds like a good number. You run through the math, check it. If you get something different, do it again. Make sure you got it right. Always double check yourself if you got time, right? Okay, so hopefully this helps you out with your y easy problem. Okay, y easy, it's a little bit different method, but really all it amounts to doing is tilting your head. Okay, so you just tilt your head and you work through it like that. There probably is a way, if you got one of those fancy TI Inspire calculators, I think you can graph relations. The TI-84 though, which is what we use for this class, I'm not sure if there's a way to do that. So maybe there is, and if there is, shoot me an email, telling me how to do that, right? That'd be kind of a good thing to show you in a video. You can look that up on your own time if you're interested in doing that. All right, guys, good luck as you go through your homework problems and dealing with the y easy problems. At the end of the day, all you got to remember, tilt your head.